When people first use Meteor, a lot of times they say that Meteor is magical, and it takes care of all these things for you. It takes care of integration with the database, syncing data from client to server, including access control rules, allowing you to run remote procedure calls on the server, and updating the display in the browser automatically. And a lot of times people's experience with that is kind of like it's almost too magical. I don't understand how it works, and it's kind of like this black box. And in this talk, I want to kind of break that conception a little bit and talk about how Meteor is built up and actually explain that Meteor is built out of a set of modular packages, each of which have well-defined and well-thought-out APIs. And these packages talk with each other through these well-defined APIs. So different packages can be replaced with others, or new packages can be created. And actually, the system is set up to enable it to do a large variety of things, not only the ones that come out of the sample demos with a Mongo database and a browser connected to it with displays that update all the time. For example, the livedata package in Meteor Core implements the DDP protocol. The DDP protocol is the basic way that all Meteor apps communicate between the browser and the server. It allows a server to send data updates to the client as they're happening. And it allows the client to go and initiate changes on the data on the server whenever it wants to. In addition, we have other packages that integrate with the livedata package. For example, Mongo livedata implements listening to changes in a Mongo database and sending those changes down the wire using the DDP protocol. Mongo livedata integrates with the livedata package using the livedata package's interface. If you understand how these packages are set up and the modularity within Meteor, you're capable of building all sorts of apps that aren't the traditional type that you usually see in the demos. And I'm going to show a few examples of those and what capabilities you can gain by understanding the distinctions between the packages inside of Meteor. I have a small sample app here called Publish Time. What this app does is just send to the client the current time. I'll make this bigger. The current time on the server. It's kind of a weird demo because in this case, the server is running on the same machine as the client. But you can imagine if you had different time zones, this might be interesting. I can open multiple tabs to this app, and they all get updated. You can see in the server log that it shows you how many connections it's sending it to. Let's see how this is implemented. This is the only HTML file for this app. Bigger? Yeah, why don't you say it? There's one HTML file that just has this simple template that uses this time helper to display the current time. The JavaScript file does a bit more, but it's actually very short. On the client, all that happens is we define the time collection and subscribe to time, which is going to be published by the server. The time helper, all it does is look for the one document in the times collection and return the time property on that document. What the server does is publish one time document with the current time on the server. But it does this without a Mongo database at all. So this uses live data without Mongo live data at all. And it is a custom publish function that just publishes the current time. How does this work? Inside publish, we use the low-level publish API to send a new document with the current time on the server. When we call self.added, we pass it the collection name, which is time, the ID for the document. In this case, because there's only one document, I took the liberty of just giving it a funky name, singleton. But you can imagine sending many different documents down to the client. And the document that's sent down just has one property, time, with a current date on the server. Then we call ready to tell the client that the initial data load is done. The initial data is sent to the client. Then we write a little bit of code just to keep track of the open connections to the client. Then we have one call to set interval, so that once a second, we take all these active publish handles, and on each one of them call changed to notify the client that the value of this one document has changed to the current date time on the server. So I'll say it again, there's no Mongo database involved at all here. In fact, this app works without the Mongo live data package at all. Yet it still uses live data and the DDP protocol to communicate these changes to the client. If I close the tab, you might expect this number from 4 to go down to 3. That will actually happen around 1 minute from now. It's intentional that we don't close connections immediately, because imagine that you're on a mobile client and you go through a tunnel, for example. You might lose connectivity for a short period of time, and it would be unfortunate if once you reconnect, you had to load all of the data once again. Actually, that's currently what happens, and we can fix this in the future. But live data is set up to allow for these connections to stay open as far as the server is concerned for a while, and the server can keep track of what data the client knows about, so that when it reconnects, if it's within a reasonable period of time, then it'll be more efficient. So if we were to wait another 30 seconds to a minute, we would see this number go down. And I guess you'll just trust me that that happens. I want to show you another example. It's a very different kind of how you can use live data to your advantage.
I have a question about the example in the show.
Yeah.
Can you switch back to code?
Yeah. Sorry, no, it's here.
Why do you have for each publish handle to publish separately?
You can imagine different, sorry, I'll repeat the question. Thank you. The question is, why do you iterate over all the publish handles and call each on them to publish? And the reason is because you could also imagine that different clients get different data. And so this is how you would be able to do that. For example, in the real Meteor, with Mongo Live data, you can define access control rules. And so you can have different clients have different sets of data. Does that answer the question?
Yes, but I would ask you, can you do it without iterating over each client? Like do it once to the data and then add client?
The question is there a way to do it without iterating over each, changing the data just once? Yes. But I'll show you the next example. You'll see us using mini Mongo on the server, and I think that will help answer the question you just asked. And if not, you can ask it again at the end. Yes. And it went down to 3 in the meanwhile. So thank you for the question. I could show that this works. Let's look at a very different example. This is an example that Sam Hatum asked me a few Devshops ago. He had to build something like this, and he wanted my advice. What we have here, sorry, let me get to the right version of this. What we have here is a small app with 2 sticky notes, though it works with any number of them. And these can be dragged, and their position gets synced between all open tabs. Let's look at the code for this app. The HTML file is very, very simple. There's just an all notes template. Sorry, should I make it bigger? Whenever it should be bigger, you should all say bigger. We iterate over the notes helper. We'll see the JavaScript in a second. For each one of them, we render the draggable note template. Draggable note is very simple. It just renders one div and puts its position based on the top and left properties of the document it's iterating over. In the JavaScript code, we can see how this works. There's a notes collection. The notes helper, which we were iterating over, just returns all of the documents in the notes collection. When we press down on the mouse, it keeps track of the active note being moved and the offset between the mouse position and the top left corner of the note. When we move the mouse around, all it does is update the notes document in the notes collection with the new top and left coordinate appropriately. The server does almost nothing. It just initiates these first 2 notes. And that's it. The way this works is that when we update the notes collection, thanks to Meteor's automatic reactive UI, it will update this template with the new values for top and left. So there's very little work needed to be done to make these things update in real time. The problem, though, with this app is that it's not smooth. And you can see that even though I'm talking with a service on the same machine, these changes don't get updated instantaneously. The reason for that is because we're still going through Mongo to implement this. And the way that that works is we have to enact the change in Mongo, and then Mongo livedata goes and listens to these changes in all the Mongo collections, tries to see what has changed, and sends those diffs down to the client over DDP. And that's a costly operation. So at the time when Sam talked with me about this, he said, well, why don't you just keep in memory the position of the node while it's being dragged? Well, we can do that. This is a second version of the same app. The differences are that instead of a notes collection, I now defined a transient notes collection. The transient notes collection is passed with this option, connection null. This is a new feature in Meteor 065 that allows you to define a collection that's not backed by a Mongo database, but rather backed by what we call mini-Mongo. Mini-Mongo is another Meteor package that implements the Mongo API on top of an in-memory JavaScript data structure. So you get the same interface as Mongo, but it's much faster. But it's also not an actual database. We then publish all these transient notes on the server. And on the client, we subscribe to them. The only one additional change in this version is that because this isn't a real Mongo collection, we don't get the automatic insert, update, remove operations. So we have to define a new method called update note to take care of that for us. And then on mouse move, instead of calling notes.update as we did in the previous version, we now call the update note method. All the rest is the same. Let's look at how this behaves. You can see that it's much smoother now. Does this solve our problem? Can we ship this version? What was that?
Probably not if you're asking.
They said probably not if I'm asking. We can't ship this because the data is not stored anywhere. You can see that if I now kill my server and restart it, once these clients reload, the position jumps back to the initial position that's specified in the code. So if we want to actually use this technique but create a real app, we have to have a hybrid approach. The solution is to make it so that we keep the data in a transient collection that's not backed by Mongo while we're dragging. But when we drop the note, we actually store the value in Mongo. Let's see how that works. Let's look at what we have now in this version. On the server, we define the transient notes collection and publish it as we did before. In addition, though, we also have the notes collection as we did before, which is a regular Mongo-backed collection. What this is going to do is have these two collections with the same IDs, where transient notes shadows the actual notes that are stored in Mongo. Update note now is slightly different. If a transient note does not exist with that ID, it creates a new one. Otherwise, it updates the one that already exists. And top and left are no longer properties, but rather they are helpers. And what these helpers do is look for the transient note document corresponding to that ID. And if that can be found, it returns the top and left of that document. And if not, it goes and looks for the regular notes document that's actually stored in Mongo. So as things are being dragged, it will have a transient note document, and that will be the value for top and left here. And once we let go, then it'll store it in the notes document. And that can be seen here. On mouse up, it goes and actually calls notes.update, which actually stores it in Mongo. Let's see this in practice. Dragging is still very smooth, but I can now go and kill my server, and it reloads, and they're still positioned in the same place. This is a real solution to the problem. There's one more layer that isn't fully solved here, which is that we still assume that all the clients connect to the same server. A full solution would be to use a fast in-memory database, for example, Redis, and have a Redis live data package that clients can use to connect to implement their transient notes collection. What I hope to show in this talk is that DDP is a generic protocol that's well suited for a variety of apps, can be used with various backends and databases, and also various clients, including mobile apps. If you have multiple servers running in this example, a Redis live data package could come in handy, but that does not yet exist. There's actually a potential way to use the current Meteor abilities to do something similar, but slightly less efficient. You can use server-to-server DDP to have all of your Meteor servers communicate with one server that works as the in-memory database using mini-Mongo. That's something I've never tried, so it may not actually work the way that I think it would. But it's the kind of thing that you can do with DDP. It's very flexible, and it has all sorts of capabilities. Meteor makes starting to build your app very simple. And a lot of people, when they have that experience, they think the Meteor is not suited for production apps. But every part of Meteor has been designed with the intention of allowing you to adapt with it to your growing needs for your app and growing capabilities. Once you understand the way the packages are constructed, you can replace packages with other versions or use their APIs to do things that aren't what some of the demos show that you can do. Meteor is not set in stone as to one way of working. I hope this talk helped people understand that Meteor's package system is actually well thought out and modular. And I hope in the future we can have similar talks for the other packages in Meteor. For example, the reactive UI system, the hot code reload system, or our account system, or many others inside of Meteor. We should also have better docs for these things, and that's something that our website definitely lacks right now. We want to make sure that Meteor solves all the real problems that people are hitting now, and we think that's a major focus that's more important right now than documenting the packages. We're trying to take it one step at a time, but we'll get there. Thank you. Questions? Yes?
So for the notes example, you had sort of a very application-specific way of documenting the transit database into your system. But it seems like you could also be able to set up some sort of like generic replication of one to another. Is that possible?
The question was, in the notes example, we had a custom application-specific way to replicate the data between this transient collection and the actual Mongo back collection. But is there a generic way to do that for a large class of apps? I don't know. That is, it could be imagined such a way to be built. If you'd like, you can try to come up with a way to do that. I've not thought about that enough. Yes?
You know, this has been discussed a bit online, but how feasible is it to use Meteor with a SQL database?
The question was, how feasible is it to use Meteor with a SQL database? The answer is, in the broad sense, it is very feasible, and it will be possible. The reason that it's slightly harder to work with SQL than it is with Mongo is because you have to think about how joins map onto Meteor's data structures. A simple way to do this, and there's a project out there that exists. I think if you search for Meteor SQL, you'll find a project. And what that does is it takes joins on the server and maps them to nested JSON object that gets sent down to the client. So you still have a Mongo API on the client, but you have SQL on the server. Over time, you might have a different approach where you have SQL on server and on client using a mini SQL package. But that's stuff that we don't know all the details about yet, and we're going to have to work that out. Yes?
I noticed in your code that you used just the regular set interval and not the meteor.set interval, and I'm wondering what that was for.
The question was, why did I use set interval and not meteor.set interval? That's a good question. It's hard to understand the technical answer is meteor.set interval also calls additional things that allow you to access Meteor internals in a way that set interval doesn't allow you to do. And in this case, it just didn't matter. But generally, you're safer using meteor.setInterval.
Any other questions?
Right. Thank you, everybody.
All right. Thank you.